Welcome to this video of applied electricity. We're going to be solving calculation involving capacitors. So this is the question. We are given two capacitors A and B connected in series. These are the capacitors A and B connected in series. So across a 100 voltage supply, this is the 100 voltage supply serving for these two capacitors. So, and it is observed that the PD across them are 60 volts and 40 volts. So you can see that the VA respectively, so the VA is for the CA, which is 60, the VB is for the CB, capacitor B, which is 40. So with this we can use our formula that says C1V1 is equals to C2V2, but here we are using CAVA is equals to CBVB. So then let's just put in our formula. So we know our CA to be CA, then what's our VA is 60 equals what's our CB, and our VB is what, 40. What you can do here is to divide both sides by the common factor, and the common factor here is we can use 20. So let's say 20 here, 20 here, 2, 20 here, 3. So here we are having 3CA is equals to 2CB. So here we can make C substitute to the formula, or let's leave it like that so that when we get our second equation we can know where to insert. So let's call this equation 1. So this is equation 1. Let's read the equation further. So now a capacitor of 4 microfarad is now connected in parallel with A. You can see that this was later connected to this in A. There was nothing here before initially. So but now they've connected a capacitor of 4 microfarad in parallel with capacitor A. So what they are saying now is that when they connected it to this, your new CA will be CA plus 4, not ordinary CA again. So and now the potential difference across B rises to 100 volts. That means you're no more using 60 and 40, you're now using 100. In a nutshell, we are going to be solving that. So this is what I'm saying here. So our new CA now is CA plus 4 because it is connected in series with the capacitor. CA plus 4. What's our VA? Our VA is no more 60, remember. It has now rise to what? To 100. So we are having 100. It's multiplication here equals to, what's our CB? Our CB means CB and multiplied by 100, the second vote. That's the new vote. So here we can multiply both sides by 100 here. 100, 100. So 100 can cut 100 here. Then we are going to be having CA plus 4 equals CB. Let's call this equation 2. Now we have equation 1 and we have equation 2. Let's assume we want to get CB and we have CA here. So let us make this place, let us make CA substitute to the formula so that we can insert it here. What am I saying? You can just say from equation 1. From equation 1, you can say that CA equals to 2 over 3 CB. I just made A substitute to the formula. So when we insert CB here now, when we insert, let me write insert 2 in equation 3. We just put CB here. We're going to be having CA equals to 2 over 3 CB, and our CB now is what? CA plus 4. CA plus 4. So you can just multiply both sides by 3. If you multiply both sides by 3, this 2 is going to open the bracket, and we're going to be having 3CA equals to 2 opening this bracket to be 2CA plus 2 times 4 is 8. So 3CA, these 2CA can come and connect like terms. So we have 3CA minus 2CA equals 8. That means CA equals 8 microfarad. That's the first capacitor. And since you have a formula that you can insert your CA to get your CB, you can also just insert this here by saying CA CB rather CB equals what? CA. What's our CA? 8 plus 4. That will give us what? 12 microfarad. So this is our capacitor A, this is our capacitor B. That is the first question. And in the second question now, we are going to be solving another one. So this is the second question here. Very, very simple. We are also having two capacitors, CA and CB. And we are given voltage that are across each capacitor with another voltage that is serving for both here, both of the two capacitors. So we are asked to find PD across each capacitor, that is the volt. So we are going to be using the voltage dividers formula. Voltage divider formula. So for V1 now, remember we are looking for PD across each capacitor, that is V1 and V2. So we are going to be saying VC2 equals C1 plus C2 for V1. Then for V2 we'll be saying V is equals to VC1 over C1 plus C2. So that's just it. Very simple. So for V1, what's your V? 200 multiplied by C2 is what? 10. So this is 10 times 10 raised to power minus 6. Remember, it's in micro. Times 10 raised to power minus 6 over, then this C1 is what? 6 and 10. So you can just see 6 times 10 raised to power minus 6 multiplied by 10 times 10 raised to power minus 6. If you do that on your calculator, so I'm going to be having 125 here, 125 volts. So if you do for V2 is equals to V, our V is 200 multiplied by our C1, which is 6 times 10 raised to power minus 6, then divided by the sum of the capacitors. So if you are doing that for the second one, 75. So this is 75 volts. So we say this one is our V1, we say this one is our V2. So now for the second one, we're solving for charging each capacitor, and you know that Q is equals to CV. Note, we are going to get the same charge for both, and it's because the formula is C1 V1 is equals to C2 V2. So Q1 is also equals to Q2. So we are going to get the same thing. So let us just solve. Q is equals to C1 V1, and also solve for Q is equals to C2 V2. So what's our C1? Our C1 is 6. 6 times 10 raised to power minus 6 multiplied by 125. So we are having 0.00075. Yes. So that's for this. When we calculate for these two, your C2 is 10 times 10 raised to power minus 6 multiplied by 75. So you are also going to be having 0.00075. So that is the charge in each capacitor. The charge in capacitor, let me just name it charging capacitor 1 and charging capacitor 2. But they are still the same thing. You can see they are equal. Thank you very much. Like, subscribe, share and comment to those that need the video. Thank you.